Hello everyone and welcome to our fourth video on Arduino. So I hope you all are doing fine today, and today we're going to be looking at a very important concept. We're going to be finally starting with inputs, and we're going to be using buttons because everybody does buttons first when they start off with inputs. So let's get started. So most of you will be knowing what buttons are. So in this example, let's say the red line that I've drawn is the wire and the green arrow marks are is the current flowing through. And let's imagine that this is the button. Okay. So current will be flowing through the circuit, but then when it hits the button, current won't flow to the other side. Why? Because the circuit is not closed, it is open. So then when we push the button down, the circuit is complete and then current flows to the other side. This is a basic explanation of a button. So before we start coding the button, we should understand how the button is connected to the Arduino. We'll be seeing many hardware components today and I'll be explaining each one of them. It's very easy. So let's get started. So you know that this is the Arduino, and we have a button here. This is the button here. And then we have a lot of things connected to a big board here. We call this the breadboard. Now, for simple explanation, let's take a picture of the breadboard first. Okay, so this is a breadboard. In this breadboard, we can see that there are kind of holes. These are actually the pins. Just like the Arduino pins, you can use wires and connect them. So here you can see that the current actually flows like this in the breadboard. So you can actually add a resistor or you can add any other component to the breadboard. So the current flows horizontally and in every sequence here. Then here though, there's something different. You can see these horizontal rails. We call them the power rails. Here, current flows horizontally rather than flowing vertically, and both sides, even the bottom here, it's power rails. Okay, so we actually use 5 volts and grounds here. If you want to connect multiple devices with one 5 volt, we actually use this part of the breadboard, the power rails. But we'll be looking at that in future videos. I mean, in this video actually, in the connections. And then the thing is, you should remember in a breadboard that this line here is not connected with this line. There is a break here. Okay, so these both are not connected. You should remember that in the breadboard. So I hope you got the understanding for breadboard. If you didn't, I'll leave a link in the description so you can go see the website and understand what a breadboard is. Moving on, we have special wires here. You can see these wires. There's a blue wire, there is a yellow wire, a red wire, and there is a black wire. So these are known as jumper wires. You can see this is how jumper wires are. I think there is normal wires, but they have a metal plug at the end of them. There are three different types of jumper wires: male to male, male to female, female to female. But in this example, or in this project, we are only going to use male to male jumper wires which have a metal plug at the end of them. So they can be easily connected to the Arduino board as well as the breadboard. They just fit in directly. So the next thing in a circuit, we are going to be looking at the resistor. The basic definition of a resistor is that it converts voltage into heat energy. So it reduces the flow of electricity, or it slows down the flow of electricity. You can see here current is flowing very fast and the LED gets burnt because there's too much current. But then a resistor controls the flow of current and lets it slowly and converts the excess current into heat energy so that the LED does not get burnt out due to too much current. So this is how a resistor works, and we're going to be using it in a project to control the electricity so that many of our components don't get burned out. So hope you have them. Now, I hope that you have understood all the components correctly. Now, we are going to be looking at how the components are connected. So first, here is the button. This is the button here, as I told already. And here, this pin, it flows vertically, as I told, right? It's flowing vertically and it's getting connected to the 5 volt on the Arduino. So it gets connected to the 5 volt here, one end of the button, and then the other end of the button goes directly to the ground pin. That means is the negative pin. So we established positive and negative current in the button. Now, how do we see if the button is pushed or not? To see that, we have a wire going to digital pin number 4. This checks if the button has been pushed or it has not been pushed. So if it has been pushed, the button sends the data, I mean the digital pin reads the data as 1. If the button is not pushed, the digital pin reads the data as 2. So only two states, 1 and 0. And now we have the LED here. We all know, we know what is an LED. So for that, we're using a resistor to control the flow of electricity again. And here we're leading a wire to digital pin number 8. So here, this is the positive, and the negative is connected directly to the same ground wire as the button. So they're sharing a common ground. Okay, now let's start to code the Arduino for the button. Okay, so first we're going to initialize a variable called button pin. In this button pin is basically the pin, the digital pin in which the button is connected. Now we have connected it to 4, so the variable is 4. Now the second is the LED pin. Now LED pin, the pin to which the LED is connected. So we have connected it to 8, so LED pin should be 8. Next is the int button state. Button state, we are initializing this variable so we can read what the state of the button is, if the button is pushed or not pushed, if it's 1 or 0. Okay. Now coming to the void setup, we have pin mode LED pin output. That is correct, right? We have learned in the previous videos that the LED has to be an output. So pin mode LED pin output. Next is the button pin input. Now first time we're coming across input, right? So we know the pin that the button is connected is 4. So obviously we are taking the input. So it should be pin number, which is 4 input. So for first time we're using input. So programs will be, using input and stuff. Okay, now coming to void loop. Here is where you will be, having some new terms like if else, digital write, digital read and stuff. So let's come to the first line. Button state is equal to digital read button pin. Okay, so this basically says that we have to the state of the button 1 or 0 should be read by 4. Basically, the digital pin number 4 has to be read to see if the state is 1 or 0, if the button is pushed or not pushed. So the syntax for digital read is basically digital read, the function name, and button pin. So button pin is basically the, what is that, pin number. Pin number is 4. We have to read the state of pin number 4 and store it in a variable, and we're storing it in button state. It should be 0 or 1. We can even use the bool operator, the bool data type for this, because it also stores zeros and 1. So instead of int, we can also put bool. There is no difference. Even int can store 0 and 1. Okay, so I hope you understood this line right here. It's very easy. Now coming to if else. Now what is if else? If else is basically a block of code which will be executed if the condition is correct. So now if you look at the syntax, it is if and the condition for if. So if the condition for if is correct, if it's true, then whatever is written in the what is that, curly brackets, inside the if statement will be executed. Basically, let me repeat again. So you can see the syntax is on the screen. If condition, then curly brackets here, and the statements to be written inside the curly brackets if the condition is correct. So for example, we can say that if we press the button, the LED should turn on. That's what we have to do, right? So what we have done here is that we have put if, and the condition is that button state should be equal to high. Why equal to high? Why didn't we put a single equal to? You can see here and stuff for initializing the variable, we use a normal equal to, but then we are comparing something here. We are comparing that high should be equal to button state. Okay, so here we use a double equal to. We'll be seeing these things in future videos more in detail, but for now just say that normal equal to is used for initializing variables or assigning variables, but double equal to is used for comparing variables. So here I said that button state, if it's equal to high, that means if the button state is high, then the code written inside the curly brackets will be executed. But what if the code inside, I mean, if the condition is false, then what will happen? This is where we come to an else statement. The else statement basically says that if the if the if statement, I mean condition, is not true, then whatever is written in the curly brackets in the else statement will get executed. Remember, if this is true, then this will get executed. But if this, but then if this is false, this will not get executed, and what is written inside the else statement will get executed. So you can have multiple statements, you can have thousands, billions, doesn't matter. You can have nothing also. So that is the if and else. But remember, always with an if, you don't need an else. So if then what happens if the condition is false? In if, nothing happens. If there's no else statement and the condition in if is false, nothing happens. But if the condition is true in if, and there's no else statement, that doesn't matter, right? Because the if statement will execute and done. So hope you understood what is if else. So let's see here. So if the button state is high, LED will turn on. If the button state is low, it'll come to the else statement, and yes, LED pin is low. We have learned, right? High is 1, low is 0 in our previous videos. So LED pin high, LED pin low. So I hope you understood the code. And now let's upload this code to the Arduino and see what happens. So make sure that your board, which is the Arduino Uno, is selected, and the port, which for me is now not shown because I have not connected the board. So let's just connect it. And after I connect, you can see it automatically gets connected to COM4. Okay, now let's just upload the sketch, and I hope you can see the Arduino on the what is that, bottom right of the screen corner. Okay, now the sketch is uploaded, and let's test it. Okay, it works. Yay, our program works. And yeah, that's it. So yeah. So thank you everyone for watching our video. If you did like it and learn something today, please subscribe and like this video. So I hope you will learn something, because buttons, the connections were a bit tough, but the coding was easy. So if you didn't understand anything, please go rewind the video and watch it again. Thank you for watching. Bye.